Good afternoon, everyone. Kayane here. This is a video covering what you need to know to get started on Milestone 2. We'll also be available through Zoom, Carmen Chat, and email if you have questions regarding this video or anything else with regards to the assignment. Here is an overview of the contents of this video. Our overall objective is to have you set up a successfully converging SuperPro flowsheet for the conversion of sugarcane juice to acetone, butanol, ethanol, abbreviated as ABE, via fermentation. We will be using the diagram in the BEAMS module as a template, and I've attached that here for you. You can also find the module in the assignment page on Carmen. I will also go over the chemistry behind the sugars, the fermentation, and the concept of the open mass balance so that you can set up all the reactions in your unit ops. I'll go over what we expect you to produce at the end of your unit op train, and finally speak a bit on design and rating mode. This is the sample flow sheet from the BEAMS module, and the most straightforward way to do this assignment is to implement all the unit ops shown here. We require that you start with a sugar concentration of 145 grams per liter, and to follow as best you can the concentrations listed at various points on the page. At the beginning, you will need to convert all your sugars into glucose, and there will be more on this on the next slide. You will then go through a dilution and sterilization step. You can find the unit ops for these in SuperPro, and split off some of the glucose water mixture. This will be further diluted and sterilized and used to increase the cell concentration in the seed fermenters. The cells from here will be combined with the rest of the sugar and water in the primary fermenters to perform the conversion of sugar to ABE. You will stop after you have an output stream of your finished product, and we ask you to consider an additional unit operation to deal with any contaminated cell batches. More on that later. So, how to set up the sugarcane juice. We will be using this reference from 2011. It talks about sugarcane, energy cane, and sorghum, each as a starting point for ethanol production. Energy cane is defined as a hybrid of commercial and wild sugar canes bred for high fiber content and low sucrose, so we will be using those numbers. This paper specifically talks about ethanol production from the solids of regular sugar canes, so that information is not useful to us. Recall that we want 145 grams per liter of sugars in solution, so use the energy cane information here to get that feed set up. As I mentioned before, the seed fermenter and May fermenter both operate on the basis of glucose. The composition of sugarcane juice, however, is primarily sucrose and an equal amount of fructose to glucose, so we need to convert those sugars first before we can continue. To go from sucrose to glucose is a step known as hydrolysis, and we can model this in a simple reactor with the reaction sucrose plus water goes to glucose plus fructose. As you can see, this generates more fructose. Fructose is an isomer of glucose, and the conversion is a complicated mechanism that is beyond the scope of this class, so we will approximate it as a 1-to-1 fructose goes to glucose reaction. You can model this either with 2 reactors in a train or 1 reactor with series reactions, up to you. As I mentioned before, part of the glucose water mixture will be taken to seed fermenters for the growth of cells used in the primary fermentation. The correct cell strain for this is Clostridia, but in this assignment we will model it as yeast. More correctly, the bacteria feed off sugars and media to grow, but we will input this process into our seed fermenter as glucose goes to yeast. You will have to either add or modify yeast as a component, and I recommend assigning it a molecular weight equivalent to that of glucose. Once the reaction is complete, you will be sending the product, yeast plus water, to the primary fermenter. For the primary fermentation, we will use this chart to set up the mass balance, aka reactions. The table covers a series of different starting reagents for fermentation and the corresponding product concentration ratios of acetone, butanol, and ethanol per concentration of starting material. You will use the first column, the one belonging to glucose, to set up your mass balance, and this is why we had you convert all the sugars to glucose ahead of time. For instance, you could pick 1 gram per liter of glucose yields 5 gram per liter of acetone plus 12 grams per liter of butanol plus 0.7 grams per liter of ethanol. The coefficients are up to you as long as you pick numbers within those ranges. The total yield should be anywhere from about 0.33 to 0.42 grams of ABE per gram of glucose. The yeast will remain unreacted as we are using it as a means of fermentation rather than an actual reagent. What do we do with all the leftover products and reagents? This is where the concept of the open mass balance comes in. To address the 0.3 to 0.4 yield of ABE from glucose, we fill the remainder of the mass with the byproducts carbon dioxide, water, methane, and hydrogen. When you set up your reaction in SuperPro, you will see the mass count on both sides, and you add enough of these four, all four of them must be present, to satisfy the balance. Your total reaction should read glucose goes to acetone, butanol, ethanol, and the four byproducts. Remember to use the vent option in the primary fermenter to get rid of the gases in a separate stream. The conversion of the glucose also comes into question. Using the values from the open mass balance, you can calculate the conversion of glucose necessary to produce 0.27 weight ABE per weight glucose. The remainder of the glucose promotes yeast growth, so you will add in an additional reaction into the primary fermenter to continue producing yeast. You can use 100% total conversion instead of 99%. Coming out of your primary fermenter, we expect to see a vent stream with the four gases, a stream with ABE solution and yeast, and a small amount of glucose if you chose to use 99% conversion. Finally, we ask you to implement an additional unit operation to separate out the cells from the stream of liquid and produce a pure ABE and water stream. Finally, a few notes on design mode and rating mode. You can find this by right-clicking on your unit operations, such as one of your fermenters, and selecting equipment data. Near the middle of the left-hand side, you will find the option to pick between design mode and rating mode. If you select design mode, SuperPro automatically sizes the operations based on maximum size limits and lists how many you need for your flow rate of material. In rating mode, you specify the size and number of units for your unit operations, and you have the option of running the throughput analysis to assess your efficiency. In terms of sizing, we recommend that your seed fermenters be about an order of magnitude smaller in volume from your primary fermenters, and to adjust the numbers of each as necessary. And that's all I have for you today. Good luck, be safe, and as always, Eric and I are open for questions.